Okay, my kids are outside playing with fire. Don't worry, their mom's watching them, so I thought I'd do a video right now. We're going to talk about covalent bonding next. We talked about ionic bonding, which is where electrons are transferred. So now we're moving on to covalent, and that is simply a sharing of two electrons between atoms. Wow, that was weird. Okay, sharing of two electrons between atoms. And that two electrons, that constitutes one bond. Okay, if we have two electrons, that's one bond. We'll talk plenty more about that. So if we just draw a picture of what two atoms might look like, we have a nucleus in the middle, of course, and then the electrons on the outside, and we draw them roughly spherical because that's just how the electrons end up looking. And we can look at the forces between them. It doesn't matter what two atoms we're talking about here. We have attractive forces and repulsive forces. Okay. First thing you might notice, if we label this as you get the idea. This is the electron cloud, and that's the nucleus. So if we look at the electrons are negative, so they are going to repel each other. That is a repulsive force. Well, think about the nuclei too. The nuclei are both positive, so they are also going to repel each other. That's another repulsive force. So then we obviously need something that attracts these two things to each other. Otherwise we wouldn't have a bond. And that attraction is between the electrons on one atom and the nucleus on the other. Okay, that is an attractive force. And it's attractive because it's a positive and a negative. The nucleus is positive, electrons are negative, so they attract each other. And when these positives and negatives balance out, that is when we have a bond. Okay? So one definition I'll give you of bond length that is the distance between nuclei that maximizes the attractive force. So when that attractive force is at a maximum, that's the bond length. And we tend to think of that as static. You know, we give you a bond length for a particular molecule, and we tend to think of it as not moving, but these things are definitely dynamic. They're always going to be moving. So another way to look at this would be to look at the energy of a bond. So we're just going to draw a quick XY here. And on the y-axis, I'm going to have energy. And in the middle, it's going to be kind of weird. In the middle, it's going to be 0. So 0 energy is in the middle, and positive energy at the top, negative energy at the bottom. Okay. And along the x-axis, we're going to have internuclear distance. That is to say, the distance between the two nuclei that we're trying to bond together. Okay. And so if we look at a graph, what this graph does is it kind of goes like this. And hopefully we'll see that ends up right there at 0. Okay, so let's start out there at 0. This is where the two atoms are too far apart. So too far apart, there is 0 potential energy. That's the y-axis. They're neither attracting nor repelling. If we go to the extreme other side, maybe we can draw them. Let's erase that. If we draw them kind of squished together, these are too close. So they're so close together, the energy's gone really high, and they're going to bounce back away from each other, basically. Okay, but what we want to do is get to the Goldilocks phase, and just like Goldilocks, whoa, we want everything to be just right. So this is just right. And at that just right point, we've minimized energy, because everything always wants to be at a minimum of energy. Okay, that's a minimum of energy. Kind of go back to that analogy of sleeping on the ladder. Okay? You can't sleep on a ladder because you're just going to fall right back off. And I don't have another color. I guess I can just switch colors. Here, let's use rainbow. This distance, or where energy is minimized, that is the bond length right there. Okay, that's the bond length, though we minimize that energy. Okay, so I guess that does it for an introduction to covalent bonds. We'll talk about electronegativity and polar bonds in the next video.